In 2016, the European Southern Observatory reported finding an exoplanet that appears to be the closest to us. Proxima b is located in the habitable zone of the star Proxima Centauri. This means that there could be life on it. And if Earth suddenly finds itself on the brink of destruction, this exoplanet could become one of the best places to move to. Moreover, flying there would take just a little more than 4 light years, which is very close by space standards. But for our current technologies, this distance is really huge. In this video, you'll discover the extent of humanity's progress in space exploration, learn about an engine capable of making a spaceship travel 600 times faster than lightning, and find out when our spacecraft might be able to reach Proxima Centauri, often referred to as the New Earth. Why is it crucial to reach Proxima b as quickly as possible? The answer lies in its location within the Centris constellation in the southern sky. At the knee of this constellation's front leg lies the triple star system known as Alpha Centauri. Among the stars in this system, Proxima Centauri is both the smallest and the closest to us. Currently, Proxima Centauri is moving along its vast orbit towards Earth at an impressive speed of 22 kilometers per second. This speed is 3 times faster than that of the space shuttle. Now, we have a unique and timely opportunity to explore this promising exoplanet because after the current phase of its approach, Proxima b will continue to move 700 million kilometers farther away from us each year. This distance is almost equivalent to the space between the Sun and Jupiter. If we miss this crucial window, the potential for colonization could face significant delays, possibly extending into centuries, or it might even become impossible altogether. Proxima Centauri, the star around which Proxima b orbits, is a red dwarf when compared to our Sun. It has a diameter that is 7 times smaller, is 8 times lighter, and has a temperature that is only half of our Sun's. Although it may seem relatively modest in size and brightness, settling near this star is still considered feasible. Furthermore, Proxima b is situated 20 times closer to its star than Earth is to our Sun. This close proximity could result in a situation where one side of the exoplanet is permanently facing its star, similar to the way the Moon is tidally locked with Earth. Consequently, one half of Proxima b could experience extremely high temperatures, while the other half might remain perpetually icy. However, some scientists do not view these potential challenges as insurmountable. For instance, if Proxima b has an atmosphere and oceans, these features could help to moderate the extreme temperature fluctuations between the planet's sunlit and dark sides. The presence of an atmosphere would allow for heat redistribution, potentially alleviating some of the extreme temperature differences. Additionally, Proxima b is more massive than Earth, which increases the likelihood that it could retain both air and water. This would be essential for creating a stable environment that could support life. However, there is another concern that must be addressed: the occasional violent outbursts of Proxima Centauri. As a red dwarf star, Proxima Centauri can experience dramatic increases in brightness, sometimes by a factor of 1,000. Such outbursts can lead to a significant surge in radiation that reaches Proxima b. This heightened radiation could pose a threat to any local life forms and could also affect future human colonists, potentially forcing them to seek refuge on the planet's dark side to avoid harmful radiation. Why would existing spacecraft take so long to reach Proxima b? To illustrate the enormity of this challenge, let's set aside kilometers and use our space tape measure instead. 1 astronomical unit, or AU, defines the distance from the Sun to the Earth, which is approximately 150 million kilometers. Only 5 terrestrial spacecraft have ever traveled distances that are 10 times greater than this. The New Horizons probe, which was launched in 2006, travels at a speed of 15 kilometers per second and has already conducted its mission to explore Pluto and its moons. At present, New Horizons is moving away from the Sun by about 50 astronomical units. In comparison, the twin probes Pioneer 10 and 11, which were launched by NASA in the early 1970s, have covered distances of over 120 and 100 astronomical units, respectively. The Voyager 1 and Voyager 2 probes, launched in the late 1970s, are notable for their long-distance achievements in this space marathon. Voyager 2 has traveled over 122 astronomical units, while Voyager 1 has set a record by covering more than 147 astronomical units. When we compare these achievements to the distance from Earth to Proxima b, it becomes clear just how vast this distance is and how daunting it would be for our current spacecraft to make the journey. If the most advanced Voyager 1 were to undertake a journey to Proxima b, it would confront a formidable challenge. The distance it would need to travel is 1,800 times greater than the distance it has already covered. Given Voyager 1's current speed, completing this journey would take nearly 74,000 years. To reduce this travel time, the probe would need to be equipped with additional fuel tanks to increase its velocity. However, adding these fuel tanks would significantly increase the probe's weight, leaving no space for the essential scientific instruments required for research and data collection. This added weight would thus compromise the probe's ability to conduct its mission effectively. Without the necessary scientific equipment, the primary objective of the mission, to explore and study Proxima b, would be seriously undermined. How soon can we get new engines for interstellar flights? Fortunately, scientists have been addressing the challenges associated with probe fuel for a long time. They have been experimenting with various alternative energy sources to overcome these obstacles. However, the critical question remains whether they will have enough time to develop a new fuel-powered engine before Proxima b continues to move away from Earth. Physicists Jim Woodward and Hal Fearn from California are working on a promising project called the Mega Drive. This concept utilizes Mach's principle, which may sound like something out of a science fiction novel, but they hope it will pave the way for interstellar space travel. The Mega Drive generates vibrations and directs them using electricity and a stack of crystals. It's analogous to shaking on skates from the cold and directing that motion forward, as if using the power of a shiver to propel oneself towards a warm drink. While the idea is fascinating, its practicality depends on being highly economical. NASA has already provided funding for development, but the project is still in the theoretical stage. Without concrete progress, it's difficult to make significant advancements in space travel with this technology. British engineer Roger Scheuer took the development of space propulsion even further with his invention of the EM drive engine, which quickly earned the nickname the Impossible Drive. This engine design features a magnetron that reflects microwaves in a manner similar to a common microwave oven. The microwaves get trapped inside a cone-shaped cavity, generating a powerful thrust. The concept is eco-friendly, relying solely on electricity for its operation. However, as of now, it's not possible to determine exactly when the first working prototype will be available, which helps explain why it is called the Impossible Drive. For the task of reaching Proxima b, we require a more reliable solution. In contrast, the thermonuclear engine project is showing promising results. This engine, currently being modeled at the Princeton Plasma Physics Laboratory, would operate using the nuclear fusion energy of helium-3 and deuterium. A spacecraft equipped with such an engine could potentially reach Pluto in just 5 years, which is twice as fast as the New Horizons probe. For Proxima b, the journey would take about 42,000 years, which, although lengthy, is still a significant improvement. Unfortunately, by the time this technology could be ready, our window of opportunity to explore Proxima b may have closed. According to astronomers' projections, Proxima Centauri and its exoplanet will begin to rapidly move away from us in their orbits within 27,000 years. Currently, only one technology seems to have a chance of delivering probes there within the necessary time frame. What do spacecraft capable of quickly reaching Proxima b look like? To explore the nearest star system within the next few decades rather than thousands of years, a probe would need to accelerate to 1/5 the speed of light. This is a staggering 60,000 kilometers per second, which means traveling at a speed fast enough to circle the Earth 1.5 times every second, a truly remarkable velocity. Currently, the only project with the potential to achieve such speeds is the Breakthrough Starshot Initiative. The Breakthrough Starshot project is founded on the principle that ordinary photons, which possess momentum, can exert pressure on objects they encounter. In practice, this involves deploying a solar sail in space. The idea is that light from the sun, or a powerful ground-based laser, could push against the sail, propelling it forward. This innovative approach could potentially enable the rapid travel required to reach Proxima b within a reasonable time frame. To execute this, a conventional rocket would first launch 1,000 tiny probes into Earth's orbit, with each probe weighing just 1 gram, lighter than a computer chip. Each probe would be equipped with a solar sail, measuring 4 by 4 meters, just 100 nanometers thick, and weighing approximately half a chip. Once the sails are in place, A 100-gigawatt Earth-based laser system would fire at them for a duration of 10 minutes. This intense burst would be sufficient to accelerate the fleet of microprobes to 1/5 the speed of light, or 600 times faster than lightning. At such speeds, even a collision with a tiny speck of dust could damage or destroy the sail. Those probes that survive and manage to reach Proxima b after 20 years will have only a brief moment to capture images of the exoplanet, an opportunity that must be seized quickly. The critical task, of course, is not to forget to remove the lens cap. The images captured will then be transmitted back to Earth, a process that would take about 5 additional years for us to receive. Today, engineers are working with exceptional determination to advance the Starshot project, which aims to achieve a historic milestone in the 21st century by reaching another star for the very first time. This ambitious endeavor is driven by the desire to accomplish something monumental in the field of space exploration. As we strive toward this goal, an important question remains. What will we discover in the forthcoming images from Proxima b? Will we uncover oceans and an Earth-like atmosphere? Or will the surface reveal a scorched desert? If Proxima b turns out to be unsuitable for life, it will not signify the end of our quest. The Alpha Centauri binary system, which includes Proxima Centauri, is home to other stars with their own exoplanets. From a base on Proxima Centauri, these other planets would be within reach. Thus, we remain hopeful and confident that we will find something fascinating in the vicinity of the centrist constellation's left knee. Thank you for watching another episode of A World to Discover. If you enjoyed this video, please leave a like and feel free to subscribe. While you're still here, if the next video on your screen interests you, make sure to go and watch it.